Hello, good day. Today is nice weather. I think today it's not too warm and not too cold, and it's going to be a really nice end of our summer here in Germany. The summer overall was very hot, much more hot than usual, but nonetheless, I was doing a lot of coding stuff today, and I actually have hit 20 times streaming in English, and that is really amazing. And with the stuff that I still have on my to-do list here, I already have done a lot of work until the first patch, and this is the hardest part. And the things that are coming here are going to be easier and easier. So I'm very confident that once I hit 100 times streaming in English, the whole list will be finished. So that's something that is really interesting. I just realized before starting the stream. I just realized this before starting the stream. Okay, so what are we going to do? Yesterday we did this beautiful heart right here. Now we see the heart. It is not filled because we can apply a fate float to it, and according to the fate float, you can see that the heart will start to be filled or not to be filled. Now the problem here is we see if we have this very much at the bottom, it's still not exactly here. This smoke that's coming from the from the bottom of the heart here on the surface, it's much stronger here than it is here. And that's because we estimated their values due to having problems with implementing the functions for that. So this is something that we will look into. We will not spend too much time, but I will try to make some assumptions how we can calculate this, and then we will try to make some kind of mathematical assumptions to improve this surface algorithm. Then we will have to apply the same beat animation to the heart underneath. You see there's an empty heart and a filled heart, and the empty heart is supposed to be underneath this filled heart. So yeah, something we really want to apply to both of these layers. Yeah, so we see this is supposed to fill up and empty. Okay, then we also want to start with this peasant here. Last stream I set up some sounds for this peasant, and first I want to check if we really have enough sounds for this peasant. There was someone who pointed out that normally if you do multiple sounds for an attack, you might want to do 3 to 5. I did 2 because I want some variations, but I'm not too sure if this was a good idea to only have 2. And in the end, I think that you can argue about that a lot, but this is something that you can not really determine logically. I think the best way to find out if two sounds for the attack are sufficient is to just play the game and look how it feels. I think this is a felt value. I don't think that this was the problem that I had yesterday. I tried to think about that logically, and I want to get going. I want to finish my work, and there's a lot of other reasons that I had to not do it immediately. But in the end, I thought, actually, this is not something you have to do logically. So I think what I don't like about this sound right now, because there's only two options for the sound value, it's often that the same sound will play 3 or 4 times until the next sound plays, and yeah, I don't think that works. So if we use multiple sounds, we at least want to hear the variation. With 2 sounds, since it's completely random, there's a high probability each time, 50%, that the same sound will play twice, and after that it will be another 50%. So yeah, there's a lot of times where you will hear the same sound 2 or 3 times. The only thing that we could do about this would to actually save the sound and say, now play the other one each time. So for this, let's re-record more sounds for this. I have 2 sounds here, and we are going to do this fast. We have 2 sounds here. These are the sounds that we created yesterday. Let's listen into them. Okay, let's turn off the music. Okay, now let's mute them and re-record. So the first step is as in yesterday. There's going to the sound of the peasant that he makes when swinging his pitchfork. So for this, oh no, I don't want to record on this layer. I want to generate a new track. And record inside of this new track. Okay, let's go. Okay, now we have a lot of samples. Let's first, I was waiting here between second 21 and 22. Now I can use this for my noise reduction. Now we have a lot of samples that we can listen to. Okay, and we will immediately start to cut out those that I like. Yeah, like this one. Okay, we now have picked three sounds that we will use later. And now we're going to mute this soundtrack and generate a new track. This new track is now going to be for the pitchfork sound. And let's go. Okay, let's pick three sounds and we can mix. let's pick three sounds and then we can mix them up. So I think I made a break between 22 and 23 for our noise reduction. Yeah, like this one. Like this one. Like this one. Okay. Well, come over here. Okay, now we have all these sounds and we are going to amplify every sound first to its maximum. So that each sound is loud enough to be heard. Okay, now we have to pick two sounds. So they have to sound like this. Let's keep this in mind. Okay, now first I did pitch the peasant sounds. Peasant is a rough guy, and he's just working the fields already, that's why it's sounding so rough. Like a rough peasant. Yeah. And we are going to mix up this sound here with another sound. Okay. Let's unmute this. De-amplify this. -5. And this will be our next sound. This will be number 3. And now we are going to do the same with the next two sounds that we picked. So for some reason, this has a lot of noise. Let's cut this. Maybe not cut it. Let's try to noise reduce this. Yeah, that's much better. And this will be our 5th sound. Okay, now let's import all these sounds into Unity, give them to the peasant, and initialize them in the script. So I'm starting to open the script of the peasant. Find it. And now while the IDE is loading, I can find the peasant folder and drag in our new sounds. Here they come. So this is the IDE starting right now. And we are going to take this peasant. He has these audio source objects on him. This is not recommended what I do now. I will open him in prefab mode. So in prefab mode, this is the base peasant that you are copying into every level. So I'm going to give him 3 new items here, and each is going to have the next sound. Okay, we have a little bit of lag. It's not good. Okay, so now the peasant has 5 different sounds. So what are we going to do is we now have to initialize these sounds. And what I initially did was I had this swing sound here, and I would just get each component. But I actually just realized there's a much better and easier way to do this. By just making an array. Let me mute WhatsApp right there. If I have to be aware because tomorrow I'm going to a tournament. That's why I need to have WhatsApp open. Well, I can watch it later. So I close it for now. So let's make an array named swing sounds. And let's delete those 2 sounds here. Don't need those. So swing sounds. How are we going to do this? We know these are 5 sounds. We actually can use this here, right here, as a template. And just say these are going to be 5 new sounds. And then we're going to do the same as this code is doing here. We are going to initialize our swing sounds number 0, 1, 2, 3, 4, because this is an array. And these are going to be the component 8, 9, 10, 11, 12. No, this is not optimal. There's one thing that we could optimize here, and this is to introduce an audio source because we have a lot of audio sources here. We can introduce a new variable just for that. Let's say it's the array that we get if we get all the components. And instead of making all these get requests, we're pointing to this array. This way we save a little bit of computation. It's barely noticeable, but it's a little bit of computation that you save here, because the get components is making a call outside of this script inside of Unity, and I'm pretty sure that this call is going to be causing more resources used than using the same array over and over again. So this is actually a way how to get around that. Just some optimization there. It's on the flip side. There's if you forget something like this, nobody will notice. Really. So now I have this switch RNG, which is deciding to which sound I'm going to play. But I don't want to do this with a switch anymore. I'm going to just say I want this RNG integer, and then from the swing sounds, I want to get the RNG in the array and play it delayed with 0 delay. Okay, now play delayed is the normal standard method you use to play sounds. there actually was a method named play. This is a legacy function. Don't use this anymore. I'm a little bit confused that it didn't mark this as a legacy function. Okay, but you're not supposed to use it anymore for some reason. I think they decided that play delayed is the only function you need or something. And maybe they realized that everybody who's starting to program in Unity just wants to use play. Like that's the first thing that comes to mind if you want to play a sound. So I don't know why play is not it's not marked as red or yellow anymore. Just saying. So let me check. So we are going to have an integer random range from 0 to 6. 6 is excluded. So this can be 0, 1, 2, 3, 4, 5. Okay, we have to change this. Because if it would decide to play number 5, number 5 is 6 in an array because an array starts with 0, and this will cause a null exception. Something you sometimes have to keep in mind. So let's try out our new peasant sounds.
Hey!
I think this is enough. Fair enough. Other than that, let me remove this line. Other than that, that's fairly finished. That's nice. So I guess the peasant has 5 sounds now, and it's so since they are very similar, you can slightly hear the difference, and luckily, I did not mess up the sounds. This is a risk why this can cause a lot of time. If you mess up one of the sounds and have to redo it again and again with 5 sounds, this happens a lot. And you also saw that he has a top attack, and I did not want the other 5 sounds to be confused with the top attack sound. And but it worked. So actually nice. We can cross it out. Did only take us half an hour or something. It's just. And I really have to say just because things are taking a lot of time sometimes in development. Yesterday I wanted to go bed at 12 o'clock. I did go to bed at 5 at 0 a.m. I wanted to go to bed. I did go to bed at 5 a.m. just because I wanted to finish the functions for the hard right here, which are we going to continue right now. And yesterday I really did not want to go to bed before I finish the UI there, because I had such a bad feeling when you're going to bed and you haven't finished what you started. So let's look at this. This right here, if you just look at the heart, or if we even play, and you can even see this with the animation. Let's see how it looks today. Just reevaluate it from after 1 day of work. Still think it looks fine. However, I'm not sure if it looks all right. Let's play this in normalized mode. And let's take a look at the heart. I have the feeling that the animation of the heart is not playing correctly. So what I'm talking about is the heart sprite has an animation. I'm going to play it now. And I do have the feeling like all these bones that the heart should have somehow not moving. Is there something that's not attached? Yes. Install burst and sprite has no bind poses. Yes. There's a problem with this sprite. This does not have doesn't find its bones. Okay, there's a binding issue here. Can we rebind this? No. Let's try to swap the bone. So the problem right here is there's an animation and we're using the bones of this heart is rigged as bones. These bones help us playing the actual animation. And the problem is the heart does for some reason not find its bones. So can you please find your bones? That's unfortunate. We have to do something about that. Let's try to fix this. Let's remove this component. And add it again. Was it sprite skin? Oh. Yeah. Create bones. No. It does not want to create its bones. Hmm. I hope it doesn't have to do anything with the material. As if the actual sprite is broken. Hmm. So go into the sprite editor, go into skinning, and yes, it is broken. It actually did lose its bones. Oh no! Anyway. We can recreate the bones. Short bone here. This is the root bone. This does not have to belong. So now we can create this bone too. And actually we can improve the bone structure. You know what? I had some problems with the bones yesterday. Let's improve the bone structure. No, not like this. So I think the old bone structure was like this. Okay, now let's improve upon this and make 2 new bones here. I also want to add a bone right here. So let's auto-wake them. This going to do. This is going to apply all these bones to the heart. Oh, I don't like this too much. So actually not applied very well. Let's maybe edit the geometry. We also lost all the information about the subdivision. I think we did it like that. Yeah, that's much better. So something did not save right yesterday. Okay, let's restore the pose and see. Now we can use this to pump. Retract those bones. Yeah, and we can animate the heart with this. Well, this is still a little bit clumsy, but we are not doing to do a lot with this. Let's apply these changes and rebind them. Now we have all the bones we needed. And we are also going to, oh, what did I change? to use the material that we have for our bone. Okay, now let's go into the animator, pick the heart, and it now says it's missing its bones. So I can only guess that. Can you please let me edit you? Ah, okay. You were this was child of bone 1. It's not anymore. These are just some root name changes. And 4 is now child of number 3. Let's play the animation and look what happens. Ooh, that looks disgusting. So I guess we changed the bones back there. So which bone is causing the problem? I think it's bone number 4 and bone number 3. So let's get rid of those two. Just play the animation now. Okay. Let's start again with this animation. Record. And so the first phase, I really looked this up a lot and it took a lot of time until I figured out how to do the animation. First phase is the upper chamber is pumping, so it's extending. The upper chambers are extending. The other chambers are still waiting to be filled. So they are retracting a little bit. Okay. Then, second phase, the upper chambers are retracting very fast. You can also change the root, or we have to be careful. So it still fits the space behind the veins. And now the lower chambers are filling up. This might take a while until we have this right. You guys are going to fill up. Will it avoid about this edge here? This is not as it is supposed to look. And then the heart is going to be at its default position again. Okay, let's play the animation. There's still a lot of work to do. But we're getting there. We're getting there. I think this is a good start. You can at least see the expanding part of the upper chambers, and I think the first problem is we are retracting the lower chambers not enough at this position. So let's try to retract them even further. Then we are retracting. Oh, it's this bone. Yeah, it's this bone to change its bone influence. Because now it's pumping into the heart, but it's also stretching the lower chamber. So we have to go into the heart sprite right here, select it, and make sure that this bone, this upper bone here, does not influence the lower chamber. So how are you going to do that? We have this brush here, and this brush you can set a size. If I press Control, we can actually just subtract its bone influence. So let's do it. Let's make that this is not influencing the lower bones, lower chamber at all. Also, let's and this is looking weird. Let's move this because now this move function. And now you can see that it's much more natural. We still can smooth this a little bit. And here we go. Oh, maybe a little bit smoother. Okay, subtract a little bit more from here. And actually, I want to add more bone influence. These top parts, especially this part, because this is where it really is going to pump. And let's smooth this once again. Okay, this should be sufficient. Now when I move this bone right here, I also only affect the upper chamber, what I want. This bone right here is a little bit connected to the other lower chamber, but that's okay. You can have that. Okay, let's apply and continue animating. So right now, this looks much better. Okay, let's play. Okay, now let's improve this a little bit. Think this part right here, this looks good. This could be a little bit more top. I think this is a little bit over the top. This position looks still a little bit unnatural. Okay, I think I have an idea. Let's point the bones up a little bit more here. These bones. So we have this and this down movement. On the other side, the left chamber should be pointing outwards too. So let's try this. Let's disable the sprite behind it because it's distracting me. Okay. Yeah, I think this looks alright. I think this looks alright. It's a little bit cartoonish, but it's cartoonish in a good way, I think. So, what is missing now? I've accidentally deleted one of the UI text there. That's really not good. That's really bad. So what I mean there was a 100 here in the middle, and I actually deleted it together with one of the bones. So let's reapply this game object. So the current health text. Come on. Oh, come on. I just wanted to edit the name. Current health text. Okay, here we go. So you're a 100. And I only use anchor points for these texts. Okay, yeah, that's it. And we can now play the animation. Now let's find a bone that's not moving as much. I think bone 2 would be a good master for our text. And let's look how this looks in the game right now. Okay, the position here is not what we want it to be. Can you please revert? Yes, you can. Thank you. Let's look how it looks in game. Yeah, we have our little text here. I think the text could be a little bit more at the bottom, but that's about it. So let's set this text more to the bottom, and we will be finished with this. So to do this, we're going to reapply it. Come on, use your anchors. And is that it has actually messed up with its anchors, which is unfortunate. But working with anchors can sometimes be a little bit tedious. But the advantage of anchor points is that it's scaling with every screen size. So, okay, now we have had the text lowered a little bit. Please revert. Okay, let's play. Let's hit play and see what happens. And now I feel like it's a little bit too low. So if we set it up a little bit higher, we will maybe hit a good middle ground. So I guess they want us to use these positions like here, but because we are a child object with bones, it's really hard to edit. So let's go again. Okay, this time the anchor points were not messed up, so we can use them. But we could grab them. Please let me grab the anchor point, please. Please. We can still edit the anchor points manually. Doing this with this function right here is not really comfortable though. So we have to estimate the numbers. I want this to be just a little bit higher. So, and 5, 1, 1, 1. Okay. Apply this again to the bone, and let's test this out again. Do you need to reverb? Oh. Okay, let's hit play and see if our health text is now at a nice position. Yeah, I guess this is as good as it gets. Maybe let's try another health. Because we are even in the game not going to be able to get over 1,000 health. So let's see what happens if we have 100 health. I think it could be a little bit more to the left. So this is why making all these artistic choices takes a lot of time. You estimate a lot of values, and estimating is always on the long run. It's always going to be more time consuming. So now you're up here. You really don't want to give me a nice day, do you? Oh, I know why. It's not set to stretch mode. So now it's set to stretch mode. I can't see the anchor points though. Don't tell me the anchor points are somewhere ridiculous. Yes, they are. Okay, now he has completely messed up the anchor points. Holy. This goes on, we are going to take forever. It's not good. So stick this to the bone. And once we attach it to the bone, the rect transform is losing all of its information. This is why it is so tedious to work with it. Okay, it has a right height. Sorry, it has the right height, but it has to be a little bit more to the left again. So let's open it again. Okay, and we want to go as far to the left as we can. Have this position right here, the height. Okay, let's memorize it, because now we are going to lose all our information, I guess. Yeah, because Unity sets it up to the wrong position, so we have to reapply it. And here we go again, yeah. So this is really unfortunate. So we could go a little bit more to the left. That's the right. So I think it's lowering this value. Yeah, I think this is as far as we can go. And let's go out. Oh, I forgot to apply it to the bone again. Apply to the bone. Make sure that we use our new values, and let's hit play. No, it's too far to the left. God damn it. So I have a better idea. So I think the best way to do this is, okay, this is a little bit too high. Don't know why Unity messes up the anchor points again and again. It's really annoying me. What could be the reason? I don't know why it does this. The flip side, I don't have to know. So, let's hit play again and just look, take a look. And there's one last thing that we can do to improve this number right here. See, I think it's now at a very good position. Not perfect, but we can change that. And the best way to do this is we use the animation of the heart to change the position of the number. Okay? So let's try. I'm going to hit record right here. Go to the first position. Oh, this is fine. And now at this position, I'm not happy with the current health text. So what I'm going to do is I'm simply changing the position a little bit so I like it more. Now you can see the text is actually moving to the position that I recommend it to move to. Okay, and we're also going to change the scale a little bit because this is when the heart is a little bit bigger. So let's upscale this by a fair amount. Okay, so and now we are going to apply all the start values to the end of this animation. Now we have this number also scaling up and down with our animation. Let's hit play and look into the game how this looks. I think we overdid a little bit with the upscale, but aside from this, this is good. This is fine. This is fine. Okay. Okay, then we have finished the animation on the heart. And something that I just remembered, this pickup here, we cannot pick it up because it has no collision with the player. So let's add a layer. Oh, ooh. Adding layers is not good. I forgot layers do add a lot of resource consumption. You're not supposed to make too many layers. So let's not create a new layer. No. Because we want to have as few layers as possible. We're going to put this on the enemy projectile layer. Let's apply this. And let's look if we can pick it up. The reason why I put this pickup to another layer is I was really annoyed that it was bouncing around when enemy units could touch this, and then they would bounce around the pickup through the level. Now let's see if this what this enemy projectile layer has as a setting. So this is our matrix. You have to look at enemy projectile. It can collide with player, ground, and objects. Okay, that's fine. Okay, this is a good layer for this pickup, even though the name is misleading. Oh no! Oh no! We have a detection for projectiles in the enemy projectile layer, and there's a skill that will automatically destroy this. That's not good. Okay, let's reevaluate. I think this hintergrund layer is never used. And then I never think it is used. Let's rename this to background. Let's see if this background here is using this layer. No, it's not. Actually, this is set to the UI layer. Fair enough. If it works. UI? Wait. Seriously? Okay, it's just the layer, not the rendering layer, so it's okay. So let's rename this background layer to, and I really wish I could make a new layer just now. Oh, come on, let's reuse layer 7. It's unused. So let's make this into power up. And It's a little bit weird why power-ups don't use this layer. I think these are floatings. They're floating objects. That's why they have the default layer. And they never interact with any enemies. Okay, let's see. Let's set our new power-up layer to not collide with default, transparent, ignore, weight cast, water, UI. Power-up can collide with power-up, that's fine by me. Cannot... I only want to interact with the player. And the ground. Okay, fair enough. So, let's save. And then we are going to improve the code for the heartbeat. So we have this heart right here. And if we fill it up, you can see it disappears. Can empty it and fill it up. But we have estimated the values for this effect here on top of the blood. So the estimation is very good, actually, because you have from top to bottom, you have the effect, but it's much stronger at this position than at this position. Here you can barely see this. At this position, you can see the blood is supposed to float into nothingness, like you're really bleeding out right there. So let's go into the shaderware. And this will be the last thing we do with the shaderware. So this is the whole shader graph that we created yesterday, which is a lot of work. And this is the part that generates this effect on top. I think we can start by cleaning this up because there are some unused nodes. Can we maybe find unused nodes? Yes, we can. We actually have a function for that. We can just delete them. Okay, that's as far as it goes. And nothing changed. Okay, so we deleted the unused nodes. And then we have the part that we care about today. This will be some typical school math, pen and paper calculation. So why? Let me take out my pen and my textbook or the papers, because we are going to need to calculate this by per hand and make some assumptions. So we have this hard fact here. And if we change the fade value, if we change the fade value, we can change how much is shown by the heart and how much is not shown. And you actually can see this is what we are actually using. This bar right here is what we are raising and lowering. But if you pay close attention, you can see right here at the bottom, here, it is smaller than at the top. Let's put it to the top. Here. And that's why, because we have estimated the value and it's not accurate. So we have to make this value actually be accurate. So first we have to analyze our functions. Why are they doing this and how does it work? So we change the fade value from 0 to 1. And I think it's a linear function. So we need to find a linear function. So it can even be smaller and bigger than 1. We're not going to do this in the games later. But when it is here at this position, we need to also have our created effect to be at the same position. So what's the problem right now? Once we reach this position, these values are actually a little bit too much at the top. This is bad. And we are creating this effect right there. And then adding a value on top of it. Okay, and this will never work. Let's see. If this is at the top, it's roughly... Yeah, this is one of the problems. We're just adding a value. Oh, we're trying to scale this value with the fade. And this is also scaling with the fade. So we have to find out how this is applied by the fade and then apply the same to this multiplier. Okay, and this add here, this is just for the additional height. Because this is the actual rectangle, and we are applying this effect, and we have to add a little, to subtract a little bit of height, so that this effect is exactly on top of the rectangle. And the problem that we have is we have estimated the values, but we don't have full control right now. So the values will be always a little bit off, as long as we estimate. And on top of that, if we ever want to do a similar effect, we will have to estimate the values again. And if we do that, that will cost us a lot of time again and again. And the more we do this, the higher the probability is that we just lose more and more time just because we were too lazy to do this the first time. So we need to understand how things work. So one thing that could make things easier for us, if we would not use something that you already uses the fade float. Because this tiling and offset is creating a UV map, putting it into this flipbook, and then the flipbook is creating this effect here. And then this is already trying to shift, and we are correcting its value a little bit. This makes things a little bit more complicated. So first let's create a node and create a new UV map and put it into this flipbook. Now what will happen if we now fade? We are still going to adjust the value of this effect. And now we are completely off, by the way. But at this moment, it should be all right. Here it's okay, but we would have to reevaluate the values now. But the advantage of this is we now have full control around where we are going to shift. The algorithm has become much easier because of this. Because we are not using the same float value twice. So, are we going to cheat now? Let's maybe try to put this into the middle. Yeah, height 0.5. Width, I think we don't care about the width. As long as it's only green, yes. Okay. And tiling, we don't do tiling, I guess. No. Tiling is exactly what we don't want to do. Okay, let's use no tiling at all. Now we have this little bar. It's exactly at the middle part. See, this is at 0.5. So let us assume we start our fade at 0. At the position 0.5. Position 0. Okay, this will be down here. We can add or subtract until we hit the right spot. It should be right here. Here it is. But first we have to find out how we multiply this fade value and then add on top of that. So let's find out. Here's our other fade value that is creating the rectangle. Which then ultimately, through a lot of calculations, is going to be applied. And this is really messed up. So instead of thinking, we can just copy. This is calculating the this is the total size of the PNG. divided by the size of only the heart sprite. Oof. This is just for the cropping. And it is not going to scale. Yes, it is, but it's going to scale with this multiplier. Holy, I don't. So I actually did this, but I have a little bit forgotten how what I was doing here. So, yeah, I have no idea. Let's just plug this in here and see what happens. Oh, that's not good. Hmm. Let's create a split and only plug in the G value. Look at it again. Okay. Let's just try our luck. If maybe we have a function that overlaps exactly at the right position. Oh, that's bad. We lost some preview. We have to save and you refresh the preview, please. No. So let's refresh the data. Because without the main preview, we cannot work. The main preview is broken. That's bad. I cannot work like this. Oh, it's not broken. You just have a very, very bad value. Okay, let's put this to 0.5. Okay, this is not scaling as much as we need it to. This also is not scaling. Hmm. Okay, what did we plug in into the rectangle here? This is this tiling and offset. So this tiling and offset should actually be responsible for the height of the rectangle, I guess. Hmm. And also try. No, this should only have the height and the width. They're going to be constant. What happens if we deplug this? It's going to be a rectangle, the middle part, and if we change fade, it's not going to change anyhow. So it was right that we use this UV map for the position, and on top of it we then we then plug this into this to have the same tiling and offset and use this to be a little bit higher. So this should actually be the sufficient information that we need. Why isn't it working though? So first of all, let's delete all of these. We can just plug in this UV map here and offset. Why is it scaling differently? It would also be nice if we could read what kind of information it actually has. Oh, this is the information. So the UV map actually holding all the information for the height. But where? Is it on the G or R value? Let's try the R value. No. It's not having anything on the B and A. as it should be, because it only uses U and V. U and V are just values that UV maps use instead of X and Y, X and epsilon. Y, yeah. Because 3D objects already use them. I think the problem here is that the rectangle uses the UV map for its final position. And somehow this uses any sense of scale. So let's do this. We're going to estimate, but this time we understand a little bit more. So in the end we are using an offset. This is defined right here. Now this offset, I don't think -25 is the right one. I think this should be a positive value. But let's first try to work with this offset. Yeah, and once we move our fade effect, it immediately doesn't work anymore. So let's we also multiply first. Oh. No, that's correct. Okay, let's use positive 0.25 as an addition. And again, I don't think this will work at all. Nope. So I think this offset is a percentage. It's 0.5% of the whole map. And that's how it's higher. Fair enough. Can also increase this height of this bar, because we are going to edit it later anyway. Let's try to go for 2.5. No, it's also losing way too fast. Okay, then I have to admit that I don't know how this scales for the UV maps. I have no idea how it is applied later. No, this shouldn't work. So let's do this. Let's estimate for this position. Oh, we have to start at 0. That's interesting. So we can actually get the right add value. This is the right add value. And ladies and gentlemen, now let's set this to 1 and just change the multiplier. And it should work now. Let's go and play the effect from start to end. Yeah, it works. We can just set this to the 0. Now we know exactly how much the add function needs, because the multiplier is set to 0. So we just need to, we can just look at this value here. And now if we increase the default and set it to a very high value, we just have to make sure that we still are inside of this bar and only have to care about the multiplier. And now the multiplier is set to a really good value. So we only have to decide now how we want our effect to look. Oh man! Setting fade to 0 actually did the job. So after that we we immediately know one variable, and then it's so easy to find out the other variable. So I think we should maybe make this a little bit bigger. So if we change this height here, we are not fucking up our algorithm. How awesome is that? So I think it looks really nice. The only thing that is not so nice is that we see the the black outline here, the edge, and we can maybe try to filter that out too. So now, right now, you still see the the black outline here. So how are we going to filter that out? For that, we want to subtract the black outline from this little bar here. So let's create a node with texture. The texture is going to be the main text. And now we have to set the black to white. We have to set the black part to white. Okay. So how are we going to do this? Is simply by maybe clamping it. Clamp. Let's try clamp. And see what's happening. So we're going to plug this in. Unfortunately, we don't see anything. Why not? Okay, we just use the red layer. We can clearly see the outlines. Now let's do the following. Let's reverse this with 1 minus. Now we have this picture right here. Let's see what happens if we clamp. Okay, let's not clamp the black parts. Let's clamp the inner part. Oh, we cannot do that. Oh yes, we can. Now we have to somehow get only this white line. Maybe with absolute. No. So what we want to do is make a function with either this or this picture. Let's just think about this picture. What is 1 should stay 1. What is less than 1 should become 0. Okay. Let's go through the math notes and see the options that we have. Modulo would not work. Okay, let's try maximum. See what that does. It's turning it white. Try out minimum. That's weird. It's not working as I thought. I thought the black part would be 0. So if we apply a maximum, say maximum is 69, 0 is below that maximum, so I thought nothing would happen. So this, how does it actually work? Maybe the other way around for minimum. Yeah, okay, so I think this is actually the same as we did with the original picture. So I have a very nice idea. We're just going to multiply this with a ridiculous high number. With, yeah, that should be. We can try to make it not too ridiculous, but every of the we have to have everything right that we want to cut out later, that we don't want to cut out. Okay, so we have to put this to 9. Okay, now let's clamp this. So now you don't see anything happening, but these values here are probably above 1. So the values that are coming out of here could be, for the white part, it could be 1,000. We don't want that. We want it to be between 0 and 1. And now, if we do 1 minus, we have this picture here only with the outline lines of the heart. And now we can plug this in, make a subtract function. And we are going to subtract from this one our outlines. Okay, now we should not be able to see the outlines in the effect that we are going to play later. Let's try to apply it. And the outlines are actually gone. Now you can still kind of estimate then that they are there. So we might want to be a little bit stricter. Okay, that's too strict. Oh, okay, I see what's happening. We have now subtracted it from this graph here, but this graph, you only see these outlines, but that's not, but it has more information that we can see. We also have to clamp this because some values are beneath, are lower than 0. We don't want this. So let's clamp this and put it in here. Now we still have the normal outlines of the heart. Only the outlines at the top part are removed. So I guess this concludes our work on the shader, because I don't think that there's much else that we could maybe do. Okay, there's always more that we could do. Now we could maybe work on this outline right here, and this line right here is a little bit more efficient, because you can still see the real line. And for that, I have a really good idea. So what we actually use is this bar right here for the fading effect, and we plug it in here. So, first let's make these into a group. And call it filter outlines. And now let's add to this effect here, to this one. Let's add this one again. But we're going to multiply it. Going to add it over it. Add those two together. This one and this one. And plug in into our subtraction. Now we see that the line is not anymore visible, where we cannot see anymore where we did our effect. So we have obfuscated that very well. And when we subtract, you can see that it's actually fading. And you cannot tell where the effect is starting and ending. But we can subtract a little bit more, make this a little bit weaker. So I think like this. I think let's put this to 0.6. So like this, we are actually hiding what we are doing. The user will have difficulty telling where the effect is applied and where not. Wish there was a way to squish this down a little. On that, I would probably need a minimum or something. Let's try. It's minimum or maximum. I don't know. Just try it out. Yes, it does. Squish it down. It's maximum. So we can squish this down. Oh, with maximum it's not. With maximum it's not working so well, because it's going to make everything else white. Can we now make a minimum? That would be fun. No, then we are going to lose our information. Put clamping. About power. It's we add and subtract to get it lower. Oh yeah. It's weird. Just want a small bar exactly above the line where our little effect is going to play. Just a little tiny bar, fade above the surface, so we don't see where the effect is starting and where not. And we kind of made it work with this. But I want this to be a little bit more subtle. So controlling this is not easy. So we could also do all our stuff again and make a second rectangle and just squish it down more, but I think that would be too much processing. That's too much. I don't think this would be efficient if you can just maybe make this one better. Somehow. Actually, I think this is already a little bit too high. Next, too high. I think this would be much better. It's maybe twice square root for no reason. Okay, it's just doing its the square root. What was I thinking? So we want what do we actually want to do? We want to take this bar right here. We want the black parts of here are going down. We want these black parts to be black. These parts to be black. And these parts to be white. So I think the first step is white. Multiply this by -1, by a smaller value, and then we can clamp it. Clamp it, multiply it again. So let's see if this bar is different. Should be a little bit smaller. I cannot see any visual difference. So yes, because yeah, I get yes, now I get it. We have to this one is wrong. We have to subtract. If we subtract a little bit of value, then clamp it. Now we should end up with a bar that is a little bit smaller. Yeah. And then we can plug it in. Okay, we've done it. And this is, and now we have the effect that we are going for. Finally. Okay, maybe I want this to be a little bit lower. This is what you get. This is what you get. And it's harder to tell what we are actually doing. And I'm very happy with this. Like, when I was thinking about making this hard effect, I was thinking about, remember these games like Diablo? Like they have some kind of effect on top of this blood, and I thought, like, how did they do that? I will never be able to do that. So I'm very happy I'm even close to having such a result. Very happy about that. Now we just have to adjust the values a little bit, and then we're done. So I think this is maybe like your heart is on fire right now. This looks amazing. Okay, now let's check again what we did. Let's now just the last thing that we want to do. We're finished with our work mainly. I just want to double check that the fade value is right when we are at the lowest point, at the highest point, and after that we're going to clean up these nodes and then we're finished. So first let's look at the lowest point. 0. We see a little bit there. I guess we're a little bit and not at the right position, I guess. So let's pre-evaluate. Evaluate. Okay, now let's go to 0.9. Now we're a little bit too high, so we have to adjust our multiplier. Okay, and now let's look how it fades. I think it looks best in the parts where you don't see the veins too much and don't have too many effects over it. I think this point here, this is where it really looks cool. And on some other parts, it doesn't look as good, unfortunately. Like right here, and kind of see what we are doing here. But this is nonetheless critique on a very high level, I guess. Okay. Let's put this to 1 and clean up. Let's first try to select all unused nodes. Do we have any? I guess not. Okay, after that, we are going to make some groups. So if we later come back to this, we understand what we are actually doing. So let's first make a group only out of this one rectangle. Make rectangle on top of plate rectangle. Maybe, okay, this maybe also belongs to that group. Now we have these here. Create plate template. Plate template height set. And then we apply. Apply offset. Now these 3 here, these are also a separate group. Add shading rectangle on top to obfuscate. This is add effects together. And all of this here, this is the fog effect on top of the flat surface. Grid effect alpha map. It's effect inside out. And these are all named. Okay, we have now named all nodes. Let's save. Save. Let's test it out in the game and rate it. It works. Nice. Okay, let's hit play and see how it works together with the animation. That's the only thing that we still were not able to test. So this looks interesting when your heart is on fire. You can see your heart slowly dissolving as you lose your health. Yeah, okay. Enough playing around. What's the next thing that we are going to need? The next thing that we need is underneath this heart, there's another heart. So let's disable this. And now we have to make all the same adjustments to this heart right here. And this heart has to be synced up with the other heart. That's rough. I also don't like how this heart is looking. Like you see these veins on it. Ugh. I think this is not too good. I think it would be nicer if it would look like you look inside of the heart. So where do we start? Okay, first let's edit this sprite. This sprite. Okay. And for this sprite, we need to have the same need to have the same properties as from this heart. So we are going to into the sprite editor. I'm not sure if we need the outline. I hope not. We're going to copy everything. Can we copy everything? Copy rig. Copies the bone, mesh, and data in the current selection. Okay. We just copy everything. Okay, let's see if we copied it correctly. I'm not sure. And let's go to the skinning editor right here and paste the rig. And we did not add the bones. Fair enough. Great. What? So we can paste it, but it's now in a different position. I think this is because of we different different sprite mode here. We have to do this also with this sprite. This is unfortunate. Now we can slice this. And what is the only thing that should be different now is the pivot point. So we're going to copy the pivot point from this sprite. Oh, it isn't. It isn't. The pivot point is the same. So let's see. 346, 327. Three, 4, 6, 3, 2, 7. Okay. Center. 1, 1, 3, 9, 6, 1, 4, 5, 4. 3, 1, 3, 9, 6, 1, 4, 5, 4. Okay. It's the same values. Let's paste now. Okay, now we correctly can apply our new positions here, which is nice. And did we also copy the geometry? Bone influence? Yes, we also have the bone influence. That's nice. So we don't need to do anything. Now the heart is not at the right position, I guess. Where are you, heart? So the sprite is missing. Fair enough. Okay, let's not do this. We want this to be exactly at the same position as this. So first we're going to make this not being this child. We want to make sure that this is the right position. So for this we are going just to copy the position. Let's just copy the whole component and insert its values. Yeah, now they're at the same position. Can make this child again. We also see that the everything here is set to 0, which is nice. So now we need to add the animation. It needs to have the same animation. So we're going to add a sprite skin, add the bones, and add the animator. It already has an animator. So now we can try to apply the same material. This won't work very well, but we can at least preview how it will look. Right? Now we have a lot of effects that we don't want. If we have it both now, so we don't want to have all the effects. We want to have a new shader for the empty heart underneath. We don't want this. We don't want any of this here that is creating the effects. We only want this top half. This. We only want this for the heart underneath. The heart underneath should only have the same size, but have no effects on it. So how we are going to do this? I think we can make a subgraph. And call this heart movement vertices movement subgraph. Okay, let's not call it subgraph because then it's going to add dot subgraph. Okay, let's just hit this and wait. Okay, and as we see, only using the subgraph now with a lot of defined properties. Oh no, we didn't select this time here. No. Can we add this? So let's reverse. I don't know if we can even reverse this. Because we forgot to select one node. Pray to God that this will work. Okay, it actually did. So let's make this subgraph again. And let's make sure that we don't forget anything. Okay, now we have everything, I guess. Yeah. So let's make this now into a subgraph. We are going to overwrite our old one because that's what we actually wanted to have. And we are ready to go. Now this only takes some variables, and that's it. So let's save the asset. And now let's look at this subgraph. Okay, we need to create a new shader. How is this called? Heart bar heart. If bar heart shader. Okay. So we're going to take this name, create a new shader. I think this was unlit. Let's go inside the shader. So we want to create a node with our subgraph. And we just have to make all these variables, and then our out will be plugged into this vertex here. I think that's it. Let's compare it. Oh yeah, the other out is just here, but we don't need it. This is so that the effect on the heart is actually applied to the blood. Okay, now I'm going to drag this onto my second monitor. And what I need to do now is I have to copy every of these values with the correct name and value. So this is going to take a while. So the first one is beat speed. Oh, I actually have all the names here. I don't need to even look. How amazing is that? Beat. Beat. Oh, but I mean, I'm a programmer. I'm a little lazy. I can just if I do this, I can copy all of the values. Vector 2, another float, another float. And let's rename this to strength. Okay, let's set up every value, and I can just copy them from the old graph. We have all the values. The only disadvantage I see here is that I actually thought the subgraph would take the values from the other graph, and not that we would have to make all these nodes again. This is a clear disadvantage with this, but yeah, I guess that's the that comes with the all the negatives that comes if you don't code everything yourself and use such a graph like this. I think in order to make this the same, I would need to define all these values inside of the sub shader graph. So if I ever have any problem, I actually should define those here. I really find it weird that you can define these values here in this subgraph, but nonetheless have to plug them in later anyway. That's odd. I would like if they would just allow you to define this value here, and if you don't expose them, but you actually have to expose them, as you don't have a choice. I don't know what happens if you use custom binding. Let's try custom binding. This happens now. Okay, nothing. Let's try to override the property declaration. And let's see what this does. No, I can still see this bit strength in the subgraph. So try this. We can also close our recording right here because we are finished with this. No, this doesn't do anything. Let's put this to 002. I think this is a right value, yeah. And save it. Let's see if in this other shader graph, we will see the 002 as a custom value. Oh, it doesn't. Just check everything here. I again and look if now this default value is applied to this other shader. Oh, now it is. We actually did it. So we don't need to define this in every graph. So now we need to find out why, which of these check marks did that. And if this works, we don't need to define the beat strength for every subgraph that we are using. Okay, it's actually the custom binding. Okay. Let's give it a label. I'm not sure what this does though. And then we are going to read the documentation, how this is going to be used. Yeah, thank you. Now I know that the beat strength goes into beat strength. Oh, I can still override it if I want. Yeah, that's so cool. So first of all, I want to delete all of these values here. Now you might say, hey, that's stupid. You've put in so much work, but it's worth it. It's worth it. Just now, fill up all these fields here. We just have to fill them up. Tell them how they should be named. I can copy them from my second monitor. Not going to be much work. Give them a label. So it's not like this is going to kill us. And the great advantage is if we change anything in this graph later on, it will be applied to all the other graphs later without us doing anything. So we don't have to care about it anymore. That's exactly what I want. I don't want to care about, did I change a value here? Did I forget to set the beats per minute in this graph? That's not going to happen. And if you can make it wrong, you will make it wrong. Okay, let's save the asset. Now this should take a while. But as a benefit, we will then have the sub shader graph being set up globally. So we don't need to plug in anything. Let's see. Okay, yeah, it works immediately for this graph. we don't need to plug into anything. That's it. Now let's go into this shader graph right here. And we should now be able to delete all of these variables. We also should clean up these old groups here. We don't have them anymore. Because these are the groups from the sub shader graph. Does the sub shader graph have these groups? Yes, it does. Okay. Let's see what happens if we disconnect all these nodes here. Yeah. We can disconnect them. And now we can actually select all these. Oh. You can select everything that has to do with our beats. Oh, do we use beats per sec anywhere else? Not that I see. The only thing that we use is the main text and the fade. Okay. But we cannot save this yet because we see that there's a problem. This is not moving. Oh no. Something went wrong. So let's check if everything is plugged in correctly. Ooh. Now the question is, should we try this or not? Now Fate is still working. We don't know the sub shader graph is affecting our heart correctly. There's only one way to find out. So we save this now. Let's see the scene. Oh, this looks ugly. Oh no. So actually we messed up somewhere. Nothing is happening. Oh no. I think we have to look at the sub shader graph and save it. Maybe it's because we haven't saved it. No, I don't think so. Maybe it's I didn't save the sub shader graph. Ooh, no. Now let's look into the documentation and look what's happening with override, property declaration, and use custom binding. Okay, we don't find anything immediately because there's actually not many people googling this. At the same time, a lot of people are not able to modify shader graphs. So you often see this when you're googling that you don't find as many answers as you find for code. Because there's a lot of people who just don't get into shader graphs. So let's Google for node settings. Graph inspector. Okay, now we have something. Nice. Let's want to let's read first. Let's go for our current version. Hmm. Okay. First, let's because the documentation is not telling us immediately what we want to do. I want to hear. Let's use this override properly declaration and see what happens. Okay, we cannot edit them all at once. Save it and see if it works now in this health bar shader. No. Unfortunate. That's really unfortunate. So, what if we create a float here? Can still plug in things. Hmm. I also want to see if we can preview this maybe. Not really. So I could try to reverse everything that I did in these graphs here until we finish Control Z. No, I can't. Good cache. Okay, don't do anything. Whoopsie. Yeah, I did Control Z. Ah. Don't want to copy all of these floats. Can I maybe copy them out of here? It would be nice. Don't think so, but let's try. Oh, we can. Now we can plug them in again and see if it is even, if our problem is connected to the exposed values. Right now I have the feeling like everything is set to 0. Yes, it is. So there's a problem with the exposed values right there. Oh, that's unfortunate. That's so unfortunate, really. And now it's working again like it should be. Okay, so for some reason, if you don't plug in anything into these, it won't use the values out of this graph. I've set up these values here, but it won't use them. So we now know that the subgraph is working correctly. It's just that the values are set to 0 and that we have to plug them in individually. But that's not what we want to do. This is our main texture. Okay, we see there's nothing moving right now. And let's save this first and then look if we can somehow edit this part here. So here it's beating. We have proven that the shader graph is working. Now we have to find a way to make all these variables here accessible, being applied without overriding them with one of our values. Let's look at the graphs, what we can see now. We cannot Now, oddly enough, in this graph, let's rename this shader. This is a filled heart. Empty heart. So let's rename this. Okay. And it only looks for the main text. Okay. So first thought, okay, we haven't defined anything here. There's all these variables popping up that should be only be accessible in the sub shader graph, but that wasn't the case. And the problem is if I want to change the beat speed for both hearts. I mean, if I beats per second, let's set it to 2 here. Yeah, it's just going to set it to 2. Let's look into Unity shader graph. Override property declaration. Is it right? Declaration. Okay. Damn it. Property types. Okay, that's really weird. I have to say the description is not telling me much. An advanced option to enable explicit control of the shader declaration for this property. So they are just explaining the name. The name already tells me that. Explicit control of the shader declaration for this property. It sounds like you override the shader graph sometimes or sometimes not. Holy. Yeah, I have no idea. I have no idea. Okay, for now, I have the idea like yeah, I don't think that I think the problem. I think this should work already. I think this should work already. It's bullshit. I call bullshit. Now I might be wrong, but nonetheless, I don't get it how they want me to do this. So now the problem is still if I set this to 2, We're going to be faster here? No, this is now not going to be set to 2. This is yeah, I think this is bullshit. Okay, nonetheless, we're finished with the property. Let's apply it to our heart. We're going to create a new material for this, because later we want to set the load value individually. Later we want to change the beats per second. Okay. And apply this to our heart. Now let's see what happens if we disable this heart. Oh, we had the wrong shader. Okay, let's activate this one again. Now something is messing up with the scale of those two. And here's where it starts. Why is one not using the same values? Okay, the beat speed is different. Beat scale is different. This is how you get things messed up. And this is why I said, like, let's hope that we don't need to try these values again. This is different. This is -4. This is exactly why I didn't want to do this. Okay. Now let's see what happens if I fade this hard. Yay. So at least after all this time, we have the ability to fade our heart on top of our other heart. So after this, we're going to make the code that will there's a lot of code already finished. We only have to access this value and change it. Yeah, this is the only thing that we do have to do, and the algorithms for calculating percentage are already there, so no problem. Okay, but nonetheless, I'm going to have a small break. I need to eat. I need to get something to drink and make myself a new tea. And for you, thank you for tuning in so far. And if you're watching this later or now, thank you a lot. And see you after the break. Hello, I'm back. Got something to eat, some fresh tea, and let's go ahead and think what we are going to do next. Well, we now have to apply our changes in the health to the UI and the code, and after that we have pretty much finished. We also want to make something like increasing the beats per second, maybe for some crazy effect. Like if you put this to 2, you see, like now it's really pounding very fast, or to 4. You see, this is really pounding fast. Yeah, but let's do that later. So where are we going to start? We changed this health text. Let's see if we play the game, if it still will work. Okay. Did we disable this void here? Yes, we did. Okay. Let's play. Okay, if we get health, the UI immediately sets up the new numbers, so the numbers are still connected to the scripts, and we only have to adjust the build rate. That's the only thing we still have to do. It's so good because I already have the code here. Let's go look into it. This is the old build code here. This. It's done in the update function. It's not done immediately. Yeah, this was if you would do it immediately. What this is doing, it's going to work with time delta time and subtract a little bit every time. So interesting. So how are we actually applying things to the shader graph? For that, we are going to look into another script. Okay, Unity, stop. We don't want to go into Unity for that. It's in the enemy human death sequence. Has this? Don't find it. Can you show me? Human death. Of course, it's the last one he finds. It's under units. Okay. Human death sequence sets in the material these floats. So we also have the fate float and we have to set it. So we can straight up copy this. And then there's this material. We have to set it up. Let's also copy this. And now we can rename this material to hard material. Now we have to find this game object. So let's straight up go and find it. This function. For this we have to go into Unity and see what is it names. Full health image. It's sprite now. But let's not change it because we might have some dependencies. Full health image. Get this. Yep. Get the material. And now we can, instead of using this value here, this material, let's try to get a float. So it says this is inefficient. Oh, okay, we can read this value, I guess. That's nice. So now we are going to set the float. So there's another. Let's first override every if function. So we can paste this code inside of all these little passages here. And now we have to set the float. Now, unfortunately, we cannot set the float like we can do it with the property. We have to use this set float. So okay. And we're going to do this a lot. Can we really not just write it like this? Wait. Okay, seems like it doesn't know what we want to do. We have some lag unfortunately right now, so let's wait. Think it might have crashed because of something. No, it didn't. Yeah, you see it's not filling this up. so we have to wait a little bit. Weirdly enough, it's still working just fine with the rest of the code. You can just type in anything. But if I type in anything, the automatic search function has been disabled. Really weird there. I will restart Writer, I guess. Now, one background that I have that's very sad. I think my PC, my power supply is broken. I had problems with just starting the PC because it would then crash, freeze the monitor. And this is. Then I looked up in the events, and I saw that there's every time I even shut down the PC, it's recording a power supply failure, and this is why I think the power supply is broken. And I guess this is the last day of the power supply. And the worst part about this is I actually ordered a new power supply. It should have arrived on Wednesday, and the package delivery, they messed up with the delivery, of course. It's very urgent that I guess there's this power supply, and I was really unhappy to even pay so much money for a power supply right now, and you know, it's not even convenient to buy a new power supply when your old one is broken. It's always a little heartbreaking. Even though, plus I want to buy a new PC sometime, and having to buy parts for your old PC, which is falling apart, puts you further away from buying a new PC. So it's really unfortunate. And now the package is not being delivered. That's the worst part of it. That I ordered it immediately when I saw the power supply is broken. And the package is not being delivered because the guy who delivers it, I think he's not wanting to go up so many stairs. And this is just outrageous. When you need something and the package doesn't come. It's a time where you really hate these delivery services. Okay, why is not coming up? I'm going ahead and okay, I wanted to kill it on the task manager. Okay, this is going to take a short while. But it's really annoying. Like every time my PC starts lagging now, I think like, holy shit. Hopefully it's not the higher power supply right now. If the power supply surges, makes the power surge, and it can actually really burn your hard drive to make it unusable, and that's scary. And then you're extra mad if the delivery guy just does not want to deliver your package. That's why I really hate these situations. And now I'm on tournament tomorrow, and they say they are going to come tomorrow. I will not be there. I was there 2 times, so I don't know. They will cancel the package, I guess. That's so sad. So now I can finally try to get this hard material. And can I get the... No, I cannot get the property fade. So you have to set and get every time. Okay, that's it. Let's see if we can now finally see if we have a changing health UI in-game. And the last part, the coding card part, was the easiest part. That's shader graph. Shader graph is really nice. It's really strong. You can make these incredible effects. But on the other side, damn, it's taking so much time. Okay, let's set the health to 5,000. And immediately we see our heart rate's 50. It's going down. 500. Yes. Yes. So it's a little bit laggy because we are not in this maximized mode. Let's go ahead and give our character a little bit less health. And let's just look how it it changes according to the damage that we will take now. Yeah, nice.
Hey!
Ooh, there was a death failure. That's not good. But aside from that, let's stop right here. And now we still have something to do, of course, as we always do. So what's next? We have applied all our changes to our heart. Now, if we are dead, we want the heart to stop. And if we continue to live on, the heart has to continue again. Okay. So we can put beats per second to 0 without any worries. So what are we going to do now is we need to set the beats per second. And we have to make the determination if we die. So let's look into this script first. Let's see where this is called. This is called right here. Yes. And this is private. Yeah, of course it's called inside of the script. Right, white private, as we always should do. And then let us think more. We want, if our guy is dead, there are special functions that are going to determine that we are dead. So we don't want inside of the health UI to decide when we are dead. That is going to be decided by the character and the character only. Yeah, so let's go into the character function that does that. There's also this damage blood effect screen. I want to take a look into that. Okay, it's not controlled with these functions. Can we see where it is used? No, don't think. No, we don't see where it is used. So let's jump on the player. There's a damage UI script. This would maybe be a better place to put our effects on. So this, I'm going to define it like this. This is going to define all our things that happen if we die with the UI and what we want to display when we get hurt. And this is a very old script. I already see that this is not a good script, I guess. So where is this effect stopped? It should be stopped inside of this damage script. Okay. Be a little bit more specific. So first of all, this has the image color and the fade color. We don't really need those. Ooh, it's also using the lerp function. I hate it. Oh no, yeah, okay, it's... How is it using the lerp function? This is not a speed. And it's also not using time delta time. So we have a lot of work to do here. Because this is actually affecting how often we see this image that we have applied to it. I'm actually surprised how short this script is. So let's define some variables first. We want to be able for the damage screen. This is the border that you see popping up from the sides when you get hurt. We want to have it a public float minimum duration. Actually, this will be private, but be a serialized field. Okay. And I will set this to 0.25. Then we want to have the maximum. Maximum blood screen duration. Let's call this blood screen. And then we want to create a float. Named longer blood green point. Percentage point. Oh, what I have point. Okay, and this serialized field right here is going to be set. We'll look it up. We have a range from 1 to 0. So this will determine the health where the blood screen at your borders is displayed longer and where not. Okay. So let's first calculate. And we need to have a private float. Starting time. Blood screen. Starting time. Okay. This is when we start any effect. So let's first calculate the remaining. We also have to think about how much do we want to affect the alpha. We don't want to affect the alpha every time with 100%. It would be over the top. Let's define those two again. Just name them alpha. And instead of fade speed, we're going to this to rename this to next alpha. Next alpha value. And we're going to put this inside of this update function. Oh no. Oh. You might want to change it later. Let's not with it. So first we want to calculate calculate the next alpha value first. Okay, first let's look into what we want to do. We want to have our duration. Calculate it. Let's first find a load. It is named oh man, today I really have a problem thinking right now. Like my brain is turning to rouge. I think it's because I didn't sleep enough yesterday, because I was programming until 5 a.m., which I totally don't want to do. I'm having a little bit of a headache right now. Okay. First, we want to calculate the time that has passed. As time since third, which is going to be the current time minus the starting time. Then we need to calculate the then we have to calculate the alpha. So if we are below this damage point, so if percentage of health that we have is smaller, no, if it's bigger, is smaller, load let's not do it like this. Load equal the next alpha value when reaching maximum. Okay? Because we want to fade in first, and then we want to fade out. We have to first calculate our maximum. We want to calculate our maximum, fade into that, and then fade out. And we don't have one maximum, one static maximum. We will have different types of maximums depending on how much damage we took. If we took a little bit of damage and our character health is underneath half of your health, you're going to have more alpha applied to the damage screen, and the duration of the effect will be a little bit longer. Oof. So we don't need this to do in the update function. Actually, we need this to be a private value that we can access later. And I will tell you why. We can just calculate at this point where we get damaged. Every time this function when this function gets called, you can then calculate with the data that we have available how long we are going to display the blood border effect and how strong. And in this update function, we are only going to check if we are underneath the value that we want to, or if we're underneath. If we have passed the first, there's two time frames that we have to account for: the fading in and fading out. So we have to check if we're fading in or fading out. And if we are fading in, we have to check if we are at maximum alpha value. Okay, let's do this. Let's also create a float starting alpha. And then I will have to put a little bit in silence because this is really hard now. I have to keep all these talks in mind. Okay, my idea is to have the strength of the effect be applied. Okay, let's think. The, the strength is according to the alpha strength is according to the damage you take, and the duration is according to the remaining health you have. So if you get a lot of damage, but you still have lots of health, would flash in very hard, but also fade out very fast. So you would see, okay, that's a lot of damage, and then we also have the timing, and the timing works like this. If you're underneath half your health, the time how long this effects stand in are going to be longer. So you see as a character, as a player, okay, I'm really hurt. These effects there's effects all over the place. Okay. And it's also maximum alpha point. No. It's a value that you surpass. What do you name this? So if you surpass this value, is the strength of the effect will be increased. Maximum alpha indicator now. Maximum alpha tipping point. Total damage. Okay. And now we have to scale it. Oh dear. Now there's 2 points. Oh man. So you didn't want to display anything. So now we have to scale this value. And is between, so let's wait, math range. What's slurp? Okay, let's see. Damage percentage. We have to also define a new point. We have for this to have a minimum, so we have so many variables here. Oh, didn't think that I would come up with so many variables. So there's going to be total alpha damage point. Yeah, we need the damage dealt. Need that. No, we don't need that. No, we want to only have this in percentages. These have to be percentages. So if we have, for example, 0, 2, 0, 1, we still have 0, 1. Now we have our damage percentage. Okay, I guess this it is. This is it. Now, let's see. We deal 0.3% of damage. Yeah, this value is 0, 1. We're going to get inside of the function. If we would deal 0, 0.5 damage, we would not get inside of this function and just save the minimum blood screen alpha. Then we are going to, so this is 0.3 minus, this is 0.2. I think we need to switch this, so this value gets higher, the more damage we do. So 0.3 minus 0.2, 0.3 minus 0.1 is 0.2, 0.2 minus 0.1 is 0.1. So this would be 3. And we are going to look. 3 would be above our maximum damage cap. Now this is 0.2, this is 0.1, this is 2. This is above our maximum cap. We're going to look. We're going to the maximum blood screen alpha. Okay. Yep, that's correct. And then also for the new fading midpoint, we do want to do something similar. So first we want to, for this we need to calculate minimum duration and maximum duration. Minimum duration is going to be minimum blood screen duration. What and whatever. minimum blood screen duration. Okay, here we are going for duration. And now we have only to look. Let's say we want to reach our maximum duration if we are at 0 health. Then we want to have the maximum duration. Let's say our remaining health is 0. And at 0 we want this value here to be 1. So 0 minus longer blood screen point, it's not going to work. So this will be some 1 minus function, I guess. Oh no. Wait, it's not a 1 minus function. So if we have this at 0, this will be 1. Our remaining health is 0.4. This is 1/5. 20%. It's going to be longer. Our remaining health is 0.2. Will subtract itself from this. And 0.3 of 0.5. 60%. So we will have very long effect. Yeah. Okay. This calculation is correct. And we are going to learn, and we are going to add the starting time. So we have calculated the midpoint of our duration for the blood screen. We have calculated the next max alpha value. Now we have to compare. We do this a lot of times. And we might be in the middle of another fading. So for example, let's say the character gets hit 2 times. First attack is a very strong attack, and the second one is weak attack directly after that. Then we want to make sure that the effects for the higher damage percentage is displayed. So, what do we have here? Oh, we also have the starting alpha. So we get the starting time, starting alpha. We now want to have more information. And first, let's just plainly check if the damage we dealt is higher than the or lower if of the damage that we got before. So we also need to save the midpoint somewhere. Okay, let's compare. Okay, let's first we will have our next fading midpoint. Let's start with that. If this next fading midpoint is smaller than our new fading point, yeah, let's not put too much work now in the rest. Then the next fading point is going to be the new fading point. I think you could maybe make this even more complicated, but let's put it like that. And the new max alpha value is small. It's bigger than the next alpha value. Let's also apply. Okay. Now, holy shit, that's a lot of calculation. Okay, now let's do our next calculation. Let's do the update function. We now have the next alpha value and the next fading midpoint. So if our current let's first write following math blob. So what I want to do is I want to get the remaining duration. Duration percentage. This is going to be the starting time. No. Okay, let's not name this midpoint. Oh, yes, we can name this midpoint. Oh. What am I thinking? We just have to use these two values. Load. Time progress percentage. Okay. This is going to be the next fading point. And then now we have to calculate the lerp. Hmm. Hmm. And we need to calculate a value between 0 and 1. And this is how much we are between the blood screen starting time and next fading point. So if we use this should be our next value. So next fading midpoint. So as long as we have not reached the next fading midpoint, time time minus time. Be smaller. Let's say it like this. Let's say we get damage at time 1. Calculate next fading point 2. We are calling this function at time 1.5. And this will calculate 0.5 divided by the starting time. That's wrong. Yeah, let's start again. Time lerp is going to be the value between 1 and 0. 0 and 1. So if we start at, we get hurt at 1, we've called this function at 1, this should always be 0 then. So how are we going to do this? We have to calculate the pass time in relation to the starting time. So I think wait. Think like this. This is going to tell us how much time has passed. No, this is not going to tell us how much time has passed. This is going to tell us how much time has passed. And this will, we divide this by the next midpoint. Then, yes, okay. Then at the beginning, how much time has passed? Okay. Also have to put in some brackets here. Oof. this is going to be, let's say this is 1, this is 1, this is going to be 0. 0 of 2 is 0. Then a half a second passes. This is going to be 0, 5. This is going to be 2. Ugh. We have to subtract the same value here, and then we're finished. Okay. So if time lerp is smaller than 1, we know that we want to fade in. If time lerp is else we want to fade out. So if we fade out, we have to calculate the starting time. Oh, only want to set the starting time then if we're setting the midpoint. Else we don't want to set this. Ugh. Now we have to make sure that we don't set this. We also have to calculate the duration. We're getting more values. Next, fading duration. Yay! Okay, and I would say a short break, going to the toilet. Okay, I'm going to continue with this code, and hopefully it will not be that much work left. So next, fading duration. This is not a percentage. I don't even know if we need this percentage. Yes, we need. We actually need this. This is a time point. But this won't tell us anything. What we calculate right now here is our current time. This is just a weird way to calculate our current time. So Let's rewrite this. So this doesn't make any sense at all. This will just tell us the time. Or we can just if you type this time, the time, it will more or less give us the same value. Okay, so what we actually want to do now, we want to, if we have this time loop is smaller than 1, then we know that we are going to fade in. This is fade in, this is fade out. Let's get rid of this, because this is really not doing anything. Except for telling us the time. Not what we need. Okay. We want to do something like this. This and time loop. Let's define our color. No. Let's get rid of these colors. Let's not get rid of these colors. So let's set the color here. Why can't I use it? Okay. If we want to loop between the starting alpha let's rename this into starting color. And make this a real color. Also check if our current alpha color Oh. Alpha is smaller than with our fade color smaller than image color alpha. Holy shit, this is it's not even my code. And let's create a faded out color. Here we want to lerp. And check if this is going to make a weird step or not. So this next color has to be smaller. Alpha has to be smaller than our image color alpha. If it isn't, then we did a mistake. And I guess that's it. No, we still have to work around this third value. Then else we're going to make this third line is false. If we're hurt, we're going to make all of these calculations. But if we're finished with these calculations, oh no, it is when the IDE does this. I only don't want to do this all of these calculations if we're hurt, and if not, I want to skip it. So, is this going to work? Hell no. But nonetheless, we are going to try it out now. So I'm a little bit skeptical that this is working at all. So let's first, it needs to compile. It hasn't compiled yet. Can you please compile? Is there an error? Yes, there's an error. Yeah, the player that is calling the script now has to give us the information we need. So we need these two floats. now we give the right information, the script, and now let's see what it does. It was a lot of work for something that, yeah, we should actually maybe have done before. It was working. I don't know. So let's go and see if this works or not. Oh, no. We still have to set all these open values. Sorry. Need to go back. I'm really surprised that we used all these values. We really ended up using all the values that we defined, which were a lot. Now we have to define inside of the script here. Here. All these we have the power to now say maximum blood screen duration. I want to say a minimum blood screen duration, please 0.5. Maximum to minimum blood screen alpha. Let's always display it with 0 at 3. Maximum blood screen alpha 0.85. We can change this anytime. Longer blood screen point. We want this to be 0.5. Minimum alpha total damage 0.1. Maximum 0.35. Okay. Hey, it's not working. Yay, nothing's happening. No error, but it's also not doing anything. Did we actually mess it up? I have no idea. So I guess the first... No, it's okay. So guess we should check how far did we get. Let's debug log those two functions. And let's try them out again. And actually, I want to switch my headphones now that we have some time because it's compiling. Oh, got to hurry, got to hurry. Okay, let's see what the console says. 2 times next fading point, 2 times new next alpha value. Okay, so we did go through this. I think we also never set the next alpha value to 0 when we reach it. So yeah, that's maybe not a good idea. Then let's check if we ever do get into these functions. Let's check the time loop first. Hmm. Let's just debug log it. There's a high probability that this is not working. And for this, we can actually use the duration. It's debug log. Okay, we have a next time loop here. And the time loop looks correct. So it's going from 0 to 2 in 2 seconds. That looks also correct. So why did you not jump into this? And maybe the next image color wasn't set. The next alpha value is 0. When do we set the next alpha value? Never! Okay, that might be a problem. Yeah, that might be a problem. We have to set our next alpha value. Or oh yeah, we do set it. But at the wrong time. Yeah, that was the problem. I guess now it will work. 100% it will work now. It will work next time. 100%. Okay, but what is this misery? Starting color is the image color. Let's see when this is stopped. Only when we respawn, so. Oh, it might also be that there's no bug. Because we are using the RGB system, these values might be something between 0 and 255. I don't think so though. I don't think so though. I think in the script it doesn't use S. So let's just put this to 255 and look if anything happens at all. It shouldn't. No. That wasn't it. So let's see what gets called. Now, now this will get called. We debug locked it. It will get called. But this, yeah, this calculation is very, yeah. This was pointing into the wrong direction. It was asking if the alpha is smaller than the next. The current alpha is bigger than the next alpha, and it had to be asking if it is smaller. So now it will 100% work. 1000% that it will work. Yeah, we saw something. So the next thing that seems to be a little bit odd is that we saw the effect popping up, but then it would fade out immediately. I think it's because of this. This little line here is wrong. And the last things that we have to apply change is the duration of the fading in, fading out. We have to think about it's not just 2 seconds total duration, but it's fading in 2 seconds and fading out 2 seconds. Okay, now it's way too long. Is this ever going to get away? No, I don't think so. Okay, now it never cancels. I think it got into this function here. No, something was keeping it from fading out. Yeah, another time that there's a sign not applied correctly. We still have to define in our stop function that we want to fade out the image immediately if we ever are going to stop. So let's look at it again. Yeah, it's fading out. Something was weird. It's being faded out immediately. I don't want that. It's not my fault. So the first part word worked perfectly. This worked. But then we are suddenly looping perfectly immediately because we have to subtract 1 from time loop. Yeah, because we are bigger than 2. Okay. Yeah. Now it's 100% going to be finished. One 100%. Okay, now we have another thing that I noticed. When we are getting damaged, we want to fade in immediately in a small fraction of time. We only want to fade out very slowly if we have already taken a lot of damage. So, recoding time. Let's let's just say power first time loop. We are going to use this. The fading midpoint is always going to be this calculation. You only have to calculate the fading out point. So we need a new we need a new variable. So let's start. So maybe we should first define what we need. First, we have to restructure this into something that only looks for the fading out. Okay. Thing is, we never use this faded out point outside of this calculations. Yep. So we don't need it. So let's check. Did we initialize all important values? I think that's next fading midpoint. Is it always initialized? Yes. Next fading duration is the next thing. Yes. So let's hit start. Yep, that works just fine. Let's take more damage.
Bias loss. All circle 2 GG.
Oh, Filzlaus! Thank you, Filzlaus. What's up? I finally, after so long, after such a long time, have gotten this function to work. Whew. Yeah, GG. And thank you for showing up and following. Thank you a lot. Yeah, was very interesting to watch. Yes, it's really not the usual kind of stream that you are going to see, because coding and game development, it can be very tedious. Sometimes you just have to spend hours and hours on the same problem, and this is a little bit weird to stream, but I'm also having a lot of fun and a lot of motivation just by having sometimes random people like you just coming by and greeting me. Thank you a lot for visiting me. Are you Filzlaus, ever thinking of becoming game developer? Hmm. Well, I get going, and next thing I care about is I want this this heart. I want it to beat faster when we are having bloodlust. Was trying a lot of stuff in Unreal Engine 5, but it was really hard, to be honest. Yeah, Unreal Engine 5. So let me open Shader Graph. Unreal Engine 5. Does this look familiar? This is also like you how you program in Unreal Engine 5 your shaders. Unity copied the system straight up. They really looked into Unreal Engine and they copied their system. Looks like blueprint system in Unreal Engine. Yes, it is the same. It is the same. Now I do not like a blueprint system for doing real programming, like programming this in a kind of graph. Like you would have to for alone for such a calculation like this with 4 values. This would be really tedious and have so many boxes of blueprints. But for shaders, it's really cool. And how much time did you spend? Not that much. I think about I think about 50 to 100 hours. Yeah, but that's quite a lot. I think if you're spending so much time in a game, time just flies by. But in the beginning, in when you are getting into coding or game development in Unreal Engine stuff, it's really just the time is hard. The time is not flying by because you are having to learn so much stuff, and things are just not going to work just like you would like it to be. So you spend a lot of time there, and it's really hard to do that much stuff. So 50 to 100 hours is a lot. I think that's really a lot. So you can be proud of yourself to even spend that much. People look into Unreal Engine, spend an hour and give up forever and say, okay, no, never going to touch that again. And I understand it completely. Game development is so complicated if you're into it. If for a lot of game developers, it takes years of their lives to perfectionate their skills and hone them. And I wanted to have this game finished last year. I mean, last year, and I actually have this game on Steam, and I finished it, and I thought after that, okay, I never tested it enough, I never polished it, and actually what I put out there after a month, I thought, oh yeah, I should have done that, and there were so many ideas that I still skipped. Even though you see how much time I spend making these games, there's still a lot of to do. This, for example, here, this is my to-do list. This is everything that I have left. Still, this is going to take me 40 days, I guess. I still said, when you see this bar below me here, there, this bar, stream 100 times in English, I really would bet that when I finish this bar, the game will be finished. So just keep going and try your best, I guess. Oh, okay. Sounds like a good motivation. Oh, motivation is always good. So there's a pyramid. There's a I've read this some time ago. This pyramid, and on top of the pyramid is your dreams. You have your dreams, and if people have big dreams, that's actually the most people have big dreams. It's I think, oh no, dreams are at the bottom. So you to get something done, at least you need to have a dream and some kind of vision. The next thing is on this pyramid, it's motivation. So you have your dream, for example. A lot of people want to go on a diet or do more sports, for example, become game dev, do your homework, and become a doctor. So how this works, you have your dream, but most people can't fulfill that dream because then you have the next thing, you need the motivation. The motivation is needed, and you cannot do it without motivation to get you going into your task that you have to do then to fulfill your dreams. And at the top of the pyramid is the easiest thing at all, and that is habits. So if you go and learn every day for 10 minutes, then you have a good habit, and it's going to carry you into fulfilling your dream. And if you say, I need to spend 1 hour into doing some stuff for my dream every day, and you have the motivation, then you can build up your habit. So you start at 10 minutes, 20 minutes, 30 minutes, and in the end you do it all by yourself. But habits are actually the hardest part, and it's also why a lot of people give up on their dreams, like doing more sports or trying to be live a little bit healthier, because they don't build the habits. Because in the American propaganda, it's all just dreams and motivation, and that's enough to actually achieve your goals. But yeah, that's a little bit more behind it. So the next two functions will be to make our heart beat much faster and then reset it. So for this, we have to read out where we started. And this is just going to be a new property. I should look up how the property is really named, because if I type in the wrong name, it will lead to an error. So beats per second. Okay. Now we have our function where we can set the beats per second. This will be really quick, I guess. So we have our material, and we only have to set the beats per second if we say so. Okay, so set float on. Okay, now we have to read the starting value for that. So now we only have to use these two functions. And what I'm going to do is we want to try to set our heart rate when we have bloodlust. So there's a system when you get damaged, or if you deal damage a lot, then you get into your blood first, and we can make that your heart is going to pound in this mode, and is beating much faster than usually. So let's search where we activate it. Activate B. So in this here, start bloodlust damage, we need to reference the help UI. So like this, health UI, health UI. We don't have a reference. Okay, let's set it up. So private health UI, health UI. Okay, that's our new what's this? Okay, and now we have to initialize this value. By saying, please find it for me. Need to insert the correct name here. Okay, the health UI is named actually health UI. And now we can use this. I wish my English would be a bit better so I could answer you faster, haha. But I have to agree, I'm forcing myself into Blender at the moment. Even I've got no motivation, and in the end of the day, I'm happy about that. Sorry for my English. Phillips, I've been practicing English for years now. So I'm actually one of the few persons in Germany who had the pleasant gift to spend a lot of time with foreigners and really speak English. And aside from that, the only thing that can help you speaking a lot of English is just practicing. So just like I do now, maybe later I will need it at my job. Okay, music is a little bit loud right now, but there's no shame in that. I think if you're a gamer, you will learn a lot of English. Like you just read English every day, and it comes over time. Well, of course, you could also force learning English, but that would be too easy. Berkeley told me to force myself into English too, but I feel very comfortable in German. Well, comfort. Comfort is... Isn't that weakness? Sometimes it's okay not to be strong. Yeah, it depends on the kind of strength. But on the other side, you can't be strong in every part, in every way. I can be very good at programming, at coding, but I can't be a good doctor at the same time. So forget it. I'm not going to be a judge or something like that. I'm not going to study three different topics just to be strong in everything. Yeah. Okay, now let's see if our final touch on the character is going to work. Oh yeah, I still forgot something. Damn it. There's one thing I forgot, and it's you don't have to just set the float of the heart material. You also have to get into the animator of the heart. So for that we need the heart sprite. Always forget something. And then we'll finish for today. Because this is if I finish this task for today, I'm going to get a little bit of rest because it's been a hard time. Yesterday I streamed 12 hours because I wasn't giving up on one topic. The heart that the heart that you just saw, Phils. I did this yesterday and it took me so long to make this right. No, I did not just the heart pumping. That was the easy part. The hard part is you see this effect at the border here. So you don't see this where the fade is ending. If you look at this here, you can still see that there's an edge here. And yesterday I spent so much time trying to make this smoke effect on top of this heart. This was insane, and I did it all in shader graph. This was insane, just how long it took until I understood how to make this, because I'm not using shader graph too much. I'm actually very new to shader graph, And shader graph is everything that you need to do these amazing effects. Like this here, you see this movement in this bar. This is shader graph. If I so if I start the game, any buttons, those are shader graph. I can't start the game right now because I still have compiler errors. So let's do this first. First I have to find these two animators. Okay, found them. Okay, now I have to look at into the animator. On the value that we need to set is called. Yeah, it's beats per second. Good. And then we need a public function show that hard. That hard, not down hard. Auto function. Damn it. This is going to set the trigger. Dead. So if we die, we don't want our heart to display any beating animation. So then we are going to set the beats per second to 0 this second. Okay, now we have to make this the respawn function. FUI dot reset heart rate, and if we die, let's find the def function. This is the def. We're going to cloud help UI show that card. Okay, let's test this. And when this works, this will conclude our coding and work for today, because the task will be completed. Yay! 100%? Absolutely. I don't have anything left. There might be something that I might want to change later artistically. So maybe make the beating function a little bit different. But that's nothing that will take me a lot of time. Now let's go and get into Bloodlust. Oh. Yeah, wait. Let's just set our Bloodlust to a really low value. Like... Oh, we can't. That's unfortunate. So let's give us infinite health. Come on, damage me, damage me. Now we see that our heart is going crazy. But unfortunately, the beat is not matching its heart underneath for some reason. That's bad.
Lane.
Okay, let's die. Okay, did reset. But when we died, we did not reset all the functions to 0 beats per second. So let's just call our little function here, which we set to set the heart rate and put in 0. Okay, so this will work now. And then we have to see why did... Oh! I forgot something, yes. We have the heart material of the filled heart, but we did not change the sounds are just great. Yes, thank you. I make them all myself. All by myself. No exception. And yeah, it just takes a lot of time. I'm also recording this. So then even during stream, so if you want to look them up, they're in the VODs. You can just go out and find them. So we need an empty. I think this is filled heart material, old one. But we also need a new material of the empty heart. Now I think we don't set this value. And now every time we use this filled material, we can now use the empty material together with that. And now it should actually really work. Let's try this out. 100%, it will work. 100%. Now we are finished. First, let's give us infinite health. We see the heart is still synced up, the heart underneath. And now we see the heart is pounding really hard. Like now it's time to do some damage. But the health UI is going down hard. I think this is one of the greatest moments I've seen in this game. This is beautiful. It's working 100%. Okay, now let's set our health to 1 and die and see what happens. Come on, die. Okay, there's something wrong with our death function. We will have to do this later. So the character was not displaying his death animation. Because parameter dead does not exist. Yeah, okay, the parameter is named die. Okay, my bad. But aside from that, we're finished for today. So let's go to our little to-do list. And the heartbeat movement is going away. Now we have seen fix main character death animation. For some reason we are not playing our death animation when we are dying. But aside from this there's everything, there's nothing much to fix here. So I think this will be really easy. And this applied well to enemy graph shader. This might be a little bit harder. This should be fast, but there's a lot of risk that this will take more time than I actually think it will. And after that, this is just some coding that I will have to do. Then I have to make new videos for every skill that you can pick up in the game. You need a video where you can see what this skill does. And then we are really into testing. So not much left. We are really, really far. So you have a question. I like that there's an animation for the health bar. An animation. Yeah. So this is also so important. Why you have to animate this health bars so much. The thing is, the user starts the game, and this is the first thing he sees. His health bar. And in the first 5 minutes, the most users decide if they want to play the game or skip it. And if they see something like this heart right here and everything is nicely animated, there's a much higher chance that they are going to keep playing the game and finish the game. This is why this is so important to have this pounding heart, and this is why I put in so much effort into making this UI as good as possible, because the first 5 minutes of the game are so important, and everything that is part of that has to be polished as hell. And also you see these buttons here, for example, you see that there's some movement inside of them. Unfortunately, there's a black bar around them. This is not in the build version. This is only in the editor. So this is a bug. You can ignore that. Yeah, and you have some effects like here. Oh, this is not. Yeah, this is playing an effect. It's barely visible though. Yeah, okay. You can see there's a lot of button shaders. There's much detail in the UI. The UI is also very big. Like you see, this is just 5 buttons, but everything has a sub button. And for example, I can see how many secrets I found. I can kill myself. Okay, there's really something weird with the death animations. Going to look into that. These are all the skills that I can pick up. And yeah, I love the sound effect. I love the sound effect when you select a button. Yeah, I really think this is a nice effect. Aside from that, yeah. UI, just important. Okay, but that concludes the work for today and the stream for today. And thank you so much for tuning in, Phils. And I'll be on a tournament tomorrow, so I won't be streaming tomorrow. But on Sunday evening, so, I will be back and I will just keep working on the game. So thank you, and this is the end for today. Good night.